A person re-identification system's main task is to distinguish people across different frames. Since the images are captured by different cameras and at different times, Person Re-ID needs to overcome many challenges such as illumination, background clutter, and occlusion. Using a ResNet model as a backbone architecture as well as adding their own modifications, recent work have shown that the cross-entropy loss function is capable of learning representations that can overcome these issues. The ground truth distribution used by the cross-entropy can be considered as a Dirac delta at the correct label and 0 for the other labels, as shown in the bar graph. The use of this ground truth distribution aggravates a well-known problem in Person Re-ID. The problem is that different people can be visually similar. By forcing the network to separate these images without considering their similarities, leads the network to focus on destructive features to distinguish them, such as the background or pose. This can be seen in these images. In our work, we provide 3 simple and straightforward methods to tackle this issue by increasing the uncertainty of the model. We also make use of ResNet 50 as the backbone architecture and modify the loss function. The first method is label smoothing, where the ground truth distribution is modified so that all labels, even incorrect ones, have a uniform distribution. The second method is confidence penalty that tries to maximize the entropy of the model's output distribution. This leads to a smoother output. The third method we evaluate is the deep variational information bottleneck. This method learns a latent representation that follows a multivariate Gaussian distribution, thus pushing the representations to be similar irrespective of the input. All these 3 methods increase uncertainty of the model by allowing different labels to share some information, thus tackling the issue of visually similar inputs. We show in this work that this concept, if applied to a simple baseline, can improve the results drastically and even outperform highly specialized state-of-the-art methods. To show how these methods were able to tackle the problem of similar individuals, we compare qualitatively the results. In this image, it can be observed that the baseline model without label smoothing was unable to correctly rank the gallery images. The model seems to have used illumination and background to find similar images. These images are even more challenging since all individuals look very similar even for a human observer. However, the model trained with confidence penalty did not only focus on coarse details such as the shirt or bag, but seemed to notice the difference in shoes. These images show the effect of illumination. Nonetheless, the model trained with VIB correctly ranks the first 2 images. Thank you.